Hello class, so we'll be talking about the first question of year 2011, part of Form B. So let's look at the first question first. So I'm going to give you a little bit of time for you to read this question. We're talking about a can, the radius of 10 millimeters, that's important. Now initially empty, as you can see over here, talks about the initial condition. Now height of the water is S. S basically talks about the height of the water. Now notice that this is S prime is given in this function. Now we need to answer A first. According to the model, what is the height of the water in the end of the 60-day period? Now, so in order for us to answer A, what we like to do is this. We like to use the height of the water. Basically, we're talking about is S of 60. That is our question mark. But since what we are given is S prime, so what we can do is this. Integral from 0 to 60 for S prime of t dt would have given us, by the fundamental theorem of calculus, S of 60 minus S of 0. But the thing is, we know the value of S of 0 because they mentioned that initially it was empty. That tells us that this value must be equal to 0 to begin with. That means this integration will get us the value of our answer. So 2 sine, so let us put that into our calculator here. So we have first we're going to go for math. Oops. We passed it. If you have to go for number 9, this is the integration. So for example, our lower bound will be 0. Our upper bound was 60. Our expression is 2 sine, 2 sine of 0.03 x, close the parentheses, and then plus 1.5. And then it's a dx. If you are to calculate it, then we'll end up getting this value. So 171. That means our answer for the first question becomes 171.8. Let's see. It didn't say anything much, so we're just going to put 81 millimeters. All right. Let's look at number B for a second. B says, according to the model, what is the average rate of the change? But the thing is, since what we are given is the rate of change, so therefore what we have to do is this. In order for us to calculate average rate, we can look into this one in 2 different ways. Average rate would be simply S of 60 minus S of 0 over 60 minus 0. Or, since we don't have the function S, but we do have S prime, we can get this one by using the fundamental theorem of calculus, just like previously. 60 S prime of t dt over 60. Now we know the numerator because we calculated earlier. All we have to do is to divide by 60. So here, if you divide that by 60, then we'll get 2 point. So the answer becomes 2.86. Now, in this case indicate the unit of measure. So we're talking about numerator was in millimeters, and then this one is per day. So millimeter per day becomes our answer. Let's look at part C. C, here we have assume no evaporation occurs. At what rate is the volume of the water changing? Notice that we're talking about the volume of the water when T is equal to 7. You see, in a cylinder, because as we can see we have cylindrical can, then volume is equal to pi r square h. But in this case, h will be equal to s. So volume will be equal to pi r square s of t. Notice that height changes, but not the radius, because in a cylindrical can, radius will be the same, no matter where you look at. So how do we find out how the volume changes? Meaning v prime is equal to pi r squared, because notice that these are all constant, it doesn't change. Only thing that changes is the height. So we have s prime t. Then in this case, we are looking at, we just have to plug in 7 in this location. So what do we end up getting? Pi r squared times s prime of 7. So let's try to look into that, see what we can get. So our calculation is simply 2 sine 0.03 times 7 plus 1.5. Once we calculate, we get 1.916. So using that idea, we can write it as 1 point. Now, what is the question asking us to put it to the nearest of? Okay, since it doesn't say much, so we can just simply say 1.917. Now, since things were in millimeters, we're going to have cubic meter. The unit of the time was days, so that's how we can write it. All right. How about number? Oh, actually, we forgot to multiply the pi times r. Sorry about that. Pi r was equal to, I believe it was 10. So 10 square. Then we just have to finish the calculation. We got to multiply that by 100 pi. Then 602. Then our final answer becomes 602.2 cubic meters per day. That becomes our answer. Let's look at part D. Here we have during the 60-day period, we are looking at m of t is equal to this way. Now, we are looking at m of t in this particular way. Apply the intermediate value theorem to find the d that justifies the time where height of the water of the two cans are changing at the same rate. That means this one has to be equal to 0. So how can we do that? So since m prime of t is in fact equal to, let's try to look into this one. So 1 over 400 will be the same. And rest of them is rather simple derivative. So 9t squared. So we have 9t squared minus 60t, I believe. 2 times 30, 60t plus 330. That's what we end up getting. Now, so expression is that expression minus the other one. So what we like to do is this. Intermediate value theorem. So for example, what was the initial value? D of 0. D of 0 is simply when the first portion is equal to 0, and then the second portion is also has to be equal to 0. Then, according to our calculator, what we can do is this. 1 over 400 multiplied by 330, simply because these two values will be equal to 0, minus, right over there. So we end up getting, when t is equal to 0, sine value will also be equal to 0. So only thing that's left is 1.5. Then we get negative 0.675. But let's try to check up on the last day, D of 60. Using the calculator once again, we have 1 divided by 400 times 9 times 60 squared minus 60 times 60 plus 330. Now, minus the sine value was the second function, 2 sine of 0.03 times 60, and then negation will be distributed here, so we have minus 1.5. Then we end up getting 69.4 or 38. So our value becomes 69.38. Since initially we started with a negative number and then we ended up with a positive number, there must be a point where d is equal to 0 by the intermediate value theorem. Because in order for you to go from negative number to the positive number, you have to pass through the point where d is equal to 0, because the function is continuous. Now, using that, we can say there must be a point where these two ratios must be equal to each other. Since d of t is continuous over t goes from 0 through 60, we know that there was time equal to c where d of c is equal to 0 by intermediate value theorem. All right, that's it. I'll see you later. Bye.